This tutorial covers 3D photogrammetry and laser scan point clouds, and the various ways we can import and use them in AnalyzerPro. The first and classic application is accident scene measurement. To do this, go to Graphics, Photogrammetry, Laser Scan, and then Landscape Static Object. Next, open the file browser and select a file. This example was created with Agisoft. In the folder, 3 files must be present: a JPG file, an MTL file, and an OBJ file. Load the OBJ file. There is no difference whether you load a laser scan file in E57 format or an OBJ file. The result is the same. AnalyzerPro now converts the selected file into its program-specific format. If the model is too large, it will be downscaled accordingly, which may take a few seconds. Once finished, the model is displayed in the preview window. Now we see the road. If it has been properly aligned in Agisoft, it will be correctly aligned in AnalyzerPro as well. You don't need to do anything except click Export and give it a name, such as Street. AnalyzerPro now creates 4 files. A file named street.color.jp, which is an ortho image of the road. It also creates a file called streetDepth.png, representing the elevation profile automatically extracted. Additionally, a file named street.info.txt is created to connect these files. The 4th file is named streetMurlPKG, representing the 3D model. These 4 files are essential and should not be deleted. AnalyzerPro automatically creates the 2D ortho image. You just need to scale it by selecting it, right-clicking, and choosing Scale. Enter a reference distance, e.g. 5 meters. Clicking 3D shows the 2D and 3D windows side by side. Surface details, including vehicles, are recognizable. Uphill movement affects the vehicle's dynamics during a drive analysis. Now the second application is similar to the first, but specifically used for mountain roads, where slope is crucial. Click on Graphics, Photogrammetry, Laser Scan, and then Landscape Static Object. Choose the mountain from the Mountain folder. Now we see a mountain road. Here we want to specify the accurate slope. 3 markers are visible. Set points by selecting a point and right-clicking. Choose the measurement point, for example, point B. Then specify the distance and angle to these points. For point A, it's 14 meters and 8 degrees, and for point B, it's 4 meters and 4 degrees. Click Align, and the model is automatically aligned as required in space. Click Export, provide a file name, and the program processes and saves the file. Now, we have the 2D ortho image again. The advantage is that we have incorporated the accurate slope and scaling. Vehicles automatically recognize this slope during dynamic analysis. To demonstrate, open the vehicle dynamics, place a vehicle, set an initial speed of 1 km/h, open the coordinate window, and click Play. Watch how the vehicle accelerates downhill, accurately reflecting inclines in AnalyzerPro. Now, the third application involves damage comparison. Click on Graphics, Photogrammetry, Laser Scan, and again on Landscape, Static Object. Choose a laser scan file, automatically transformed by AnalyzerPro, into textured object files as known from Agisoft. Scale down and adjust the vehicle accordingly, then export. Perform the steps for both vehicles and assemble them. In Image Properties, make the white border transparent. Click 3D to compare damages in 3D between both vehicles. Moving on to the next use case, loading 3D models onto moving vehicles. Click on the car icon, select a 2010 BMW 5 Series from the database, Note down its dimensions: length 4.998, width 1.901, height 1.5559, and enter them. Now go to Graphics, Photogrammetry, Laser Scan, and Vehicle Moving Object. Choose the 5 series, BMW under BMW. Enter the vehicle's geometric data, length, width, and height. Scale the model accordingly, then move the base plate at the bottom of the vehicle. Remove the wheels by clicking Show Cylinders, Input Overhang and Wheelbase, click Cut, and the tires are removed. Click Export, name the file, and now you have a 3D model in MERL-PKG format. Additionally, point cloud data is converted into OBJ, PNG, and MTL files. Now, under the car icon, choose 3D model, select the file and click OK. Choose the vehicle, set a speed, e.g. 10 km per hour, and a duration, e.g. 10 seconds. Click OK. Click 3D for the 3D view. AnalyzerPro automatically adds tires to the vehicle. Adjust the track width by clicking the vehicle icon. Now you have a moving vehicle with turning tires driving through the landscape in AnalyzerPro. With that, I thank you for your attention and wish a lot of fun practicing.